Abigail. All right, so here's our study guide. Let's jump right in and see how we do. We're also going to have our calculator if we need it, so we'll look at that anytime we need to. So let's look at number one. He does if there's study guides in the back and donuts. So this says, suppose theta is in standard position and the given point is on the terminal side of theta. I tried to make these exactly like your test would be worded. Okay, so don't get bogged down in the wordiness, but I wanted the wordiness to be there. Here's the problem. Find the exact value of sine theta, cosine theta, tan theta. Okay, Joy, put the phone down, dear. Okay, so here we go. We got a point, 3, -4. Is that on the unit circle? Not on the unit circle. Okay, and of course, you got your unit circle if you want to look at it, but that's not a point on the unit circle. So it's giving us x and it's giving us y. We need to find sine, cosine, tangent. So that's where those formulas over there come into play, where we know sine is y over r, right? We know cosine is x over r, and we know tangent is y over x. We know those. All right, well, I have x and I have y. How am I going to get r? Remember this little guy? I wrote him on the board over there. Kind of Pythagorean-ish guy, right? He's Pythagorean, but he's the triangle guy. Okay, so there you go. That's who we're going to use. Make sure, if you get stuck on these problems, chances are this is what you're looking for. Okay, we're going to plug them in. So we're going to have 3 squared plus -4 squared equals r squared. My college algebra class had a complete breakdown because they had to do Pythagorean theorem. And this is what they kept doing. They kept getting the wrong answer. They would go -4 squared, you know, for b squared under the radical. And then they would write down that it's -16. Is -4 -6 squared -16? No. Why did it come out to be that? You didn't put parentheses. Your calculator thought you wanted 4 squared then times -1. So if you are doing this in your calculator, some of you do everything in it for test day. I get it. You don't want to make a stupid mistake. Put it in parentheses. Anything you square should be positive. Okay. All right. So I'm going to get 9 plus 16 equals r squared. That's a 25 equals r squared. I take the square root of both sides. Now this would give me plus or minus 5. But what does my r have to be? Positive, because it's a distance, it's a radius. Perfect. So now we have everybody we need for those 3. We're just going to plug it right in. So I kind of wrote on one of my lines, but let's just, okay, cosine theta is x over r. X is 3, r is 5. Okay, sine theta is y over r. Y is -4, r is 5. Tan theta, okay, is y over x. So y is -4, x is 3. There we go. There's no reducing. There's nothing you have to do. It's just really straightforward. So again, the 2 things you got to make sure you know so far is this guy, and you got to make sure you know these 3. Okay, that's so far, that's the info you need. Everybody good with that? Okay, let's try the next one. Okay, we have cosecant and cotangent. Now, it may not be cosecant and cotangent. It could be any of the 6. So you want to make sure that you can find any of the 6. Everybody got it? Okay. All right. But they are going to be some negative angles, just to make sure you're comfortable with it. So if I pull out my unit circle and I remember this, what's going on, or actually, let's not even do it with that because you really don't need it. They're quadrantal angles. Okay, here's my unit circle, a -270. So I'm going to start here and I'm going to go down and around. So here's -90, -180. Here's -270. I'm up here for my -270. So I need this point. What point would that be? That's just 0, 1, right? for that quadrantal point. It's 0, 1. Or if you have this all set on your index card, here's negative 270, there's your point, 0, 1. Okay, so that tells us x is 0, y is 1. What's r? 1. You're on the unit circle, right? These are unit circle values. Okay, so now for cosecant, who's his reciprocal? Sine, right? So sine is his reciprocal. So you can either look over there on your index card and know cosecant is r over y, or you can remember his inverse is gonna, that's not right. His reciprocal is sine, okay? So he's going to be r over y, okay? My r is 1, my y is 1. That makes the whole answer 1, okay? So be comfortable with negative angles. Okay, now we have negative 90. All right, we'll just do it on the same little circle. Negative 90, again, I'm going down and around. Well, that's just gonna stop right there, okay? So what's the point for that little guy? 0, negative 1, right? You don't go left or right, but you do go down, okay? So 0, negative 1, or you can pull it right off your unit circle. Okay, so for him, you're gonna have x is 0, y is negative 1, our r is still 1. Okay, so cotangent is x over y, or you can think of it as the reciprocal of tangent. Okay, so x is 0, y is negative 1. What's 0 divided by negative 1? 0. Again, don't make that silly mistake where you don't know what it is. If I put in 0 divided by negative 1, I get 0. If I put in negative 1 divided by 0, if 0 is in the bottom, look what happens. It freaks out. What does that mean when it freaks out? Undefined. Okay, so it was definitely 0 divided by negative 1, 0. And there's your answer. Okay, so far, again, all you're really having to know is this and all the little YXR situations.
We know that that is the unit circle.
For here?
Yeah.
Yes, and I'll tell you that if you want to, but yeah, you would know that. That's a good question because really it's not on there, but yeah. Okay, these two definitely calculator questions. You don't have to have your calculator in any certain mode to do this because your calculator will know what to do. But first question says, convert this angle to decimal degrees and round to the nearest hundredth. How many decimal places is 100th? 2. Okay. All right, so here we go. Remember to put that in the calculator. I'm trying to find the best place for you to see this without a glare. Is that okay? Okay. All right, so we're gonna put in, well, now I can't read it. I gotta go here. Okay, 56. Type in 56. Remember, we want to go to angle. So second angle. This is one of those things. Make sure you know how to do this. Don't ask me on Friday. There's your degree. Everybody got that? Then it's 42. Okay, we're going to go back to angle and do the little minute, right? So it's 52 degrees, 42 minutes. Then all you're going to have to do is hit enter. And there you go. All right, so if I want it to the nearest hundredth, what am I going to write? Throw a 0 on there. Okay, don't make me take a point off in trig because you don't know your decimal places. Okay, good. Everybody okay with that? Everybody got it? Okay, second angle. Ask me now if you're not sure how I got that. Write that down somewhere if you need to. Second angle is where you find degrees and minutes. They're both in there. Now, when you go to do your homework, remember seconds are down here. You'd have to hit alpha plus to get to him, but he won't have him on your test. Okay, let's look at the next one. The next one gives you the decimal version, 59.0854, and it wants it in degrees, minutes, seconds. So again, you're going to go back to angle and just scooch down here to degrees, minutes, seconds. That's it. And there you go. Now you want to round to a whole number. So we know that it's 59 degrees. We know it's 5 minutes. I will take 7 seconds or 8 seconds. It really doesn't matter to me, okay? It's up to you. So I'll take this or I'll take this, okay? Whichever way you want to do it. Okay. All right. Everybody good getting that? Just make it a whole number. Okay. Well, let me scoot up the next guy then. Okay, you're gonna have to draw now. I don't require a lot. You've seen my talent, but you are gonna have to draw. So give yourself a little circle. Give yourself the X and Y axis, right? Okay, then you're gonna get some degree. It's gonna be less than a full rotation, but you're gonna have to do 3 things, right? You're gonna have to show me movement, label it, and then tell what quadrant it's in. You need all 3 of those. Don't forget it. Most students forget the quadrant part. Okay, what quadrant is 210 degrees in? 3. So here's 1, here's 2, here's 3. I don't care where it is, just put it somewhere in there, okay? Don't pull out your protractor-ish, just throw it in there. But I do need to see movement. I need to see that arrow movement to know how did you get down there, and then label it, okay? So that would get you full credit along with quadrant 3. That's what I need to see, okay? That's it. So movement, label it, quadrant. Oh, I put 270. Label it with the right numbers and you're good to go. Okay. So just pretty basic stuff. Everybody okay with the first page? Good? Okay. All right. Number 6. Okay, number 6 gives you secant. It wants the value of cosine. Yours may not give you secant. Yours may give you cosecant. Yours may give you cotangent. The point of number 6 is, do you know that you're finding the reciprocal? Okay. And then also, can you rationalize? So it's going to be a reciprocal function. Do you know you have to flip it? And can you handle a radical in the bottom? So we know that these guys are reciprocals, which means cosine theta is just going to be the reciprocal, right? So if this turns out to be cosecant they give you, I'm going to ask you for sine. If they give you cotangent, I'm going to ask you for tangent. All you got to do is flip it. But you can't leave it like that. I need to know that you can clean it up and that your answer is going to be this, 3 root of 5 over 5. Okay. Sound good? All right. Okay. Number 7. Now is when you're going to need your unit circle, but you only need quadrant 1 for this question. It says, what is the point on the unit circle that corresponds to an angle of pi over 6? Okay, I'm either going to ask you pi over 6, pi over 4, or pi over 3. I'm just going to ask you one of the 3. Okay, one of those 3 in the first. So one of these guys is what you're going to be asked. And you have to just tell me the point. Okay, so either memorize it, draw it out as soon as you get it. We've kind of drawn it together. We know how to do that. Or you can put it on your index card. Yeah.
How come it goes just pi, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? Why are the first 3 just pi?
Hold on, I got confused. Where are we?
In the quadrant 1.
Oh, because this is 1 pi over 6. Yeah. And so that's why, and then this is 2 pi over 6, right?
Oh, okay.
And this is 3 pi over, or I'm sorry, 3 pi over 6, 4 pi over 6. You know, it's made of all those little angles, but then once you reduce them, they turn into the others. But it's the same thing. Yeah. Okay, so if I get my unit circle, okay, so in this case, pi over 6, here's my point. That's all you need to put. Just, again, it's really basic with this test. They want to know you can read the unit circle. Okay. All right, now we have some conversions. Can you go back and forth between degrees and radians? Do you know how to do that? So I wrote it on the board down there at the bottom as something I would put on your index card. To go from degrees to radians, right? You're going to divide by 180, put pi in the top. To go from radians to degrees, you're going to multiply by 180, get rid of pi. That's all you got to do. Okay, so let's make sure we can do this. Here we're going degrees to radians. So if we're going degrees to radians, we're going to divide by 180, put pi in the top. Okay, so here we go. We're going to go to our calculator. Okay. Okay, so 150, is that what we were? Okay, divided by 180. Do not put 0.8333 pi, right? You have to have a fraction. How do we get to fraction on here? Math. Frac. He's 5/6. Okay, make sure you can do that. And then we're just going to throw a pi in the top. There we go. Okay, 5 pi over 6. Perfect. Now, if you have your unit circle, it's probably on the unit circle, right? But just make sure you know how to do that. Okay, the next one says convert 7 pi over 4 radians to degrees. Okay, so to go the other way, we're going to multiply by 180, and then we're going to get rid of pi. Okay, so let's see. I have 7 pi over 4. I'm going to get rid of pi. And I'm going to take 7 divided by 4, or 7/4. I should have put him in parentheses. Put him in parentheses, times 180. There's your degrees. Make sure you put a degree on it. Put a little circle up there. Okay. Everybody good to go? Okay. All right. Then we have 9, 10, 11. 9, 10, and 11 are all about that arc length formula, but you don't have to do 9 or 10, okay? Because your arc length formula is going to be really straightforward. Your arc length formula is going to ask for the arc length. These ask for either r or theta. Okay, what is the thing we have to remember about theta? Has to be in radians. Okay, do you think I'm going to give you radians? No, so now you're going to have to change degrees to radians, right? Okay, well, we already know here's our r. Whatever r they give you, just take it. So 10. But now I'm going to have to multiply it by a radian measure. So I'm going to take 35 out here. Okay, remember how to go from degrees to rads. I'm going to divide by 180, and I'm going to put a pi in the top. Okay, so I have 35, divide by 180. You kind of see that there? Okay, math frac, I got 7/36. That's horrible. That's okay. Okay, 7, throw a pi in the top. There we go. Everybody get that? Okay, make sure you can get that. All right, and now we're just going to multiply them. Okay, so again, here's our little calculator. Okay. Just trying to do this where Abigail can see it too. Okay, all right, so I have 10 times 7 pi divided by 36. Okay, and it wants me to round to the 100th. We're not going to screw up rounding, for crying out loud. Okay, and there you go. And then if you want to put your units on, what would the units be? Centimeters, just like your radius. Okay, but I'm not going to take off points for your units.
Are we gonna have to do the chemistry stuff where we put it in?
For your bonus,
Oh, okay.
if you want the bonus, yeah,
But not in the test.
no,
Okay.
you're good. Okay, all right. Let's try the next one. Next one wants an area. I wrote that formula over there, but your area is 1/2 r squared theta. Again, with theta being a radian and you not having it. Okay, so here's our degree. Okay, so we're going to take 125, okay, divided by 180, math frac, and I came up with 25/36, but you have to put a pi in there. Okay, that's going to be my theta. Okay, so I'm going to have 1/2 times my radius, which is 18.3. He gets squared, times 25 pi over 36. Good gracious. And we're going to round to 2 decimal places. Okay, let's see how we put all that in the calculator then. How about, is that okay over there? I can't see over there. Is it too dark? How about that? Okay, all right, here we go. Okay, so 1/2, I'm just going to do 0.5 times, okay, 18.3 squared times 25 pi divided by 36. Ugh. Okay, 365.31. Does that sound good? 365.31. Okay, so again, make sure, don't say, oh, I watched you do it. I can totally do that. Put that in there. And then it's area squarea, so your units are squared. Yeah. Okay, is that page good? Like a plan? Okay. All right, now comes the quadrant work. Okay, we've got to remember in which quadrants are your functions positive or negative. Please, please, please remember that. So some of you like the idea of all, students, text, constantly. That gives you who's positive. Everybody's positive. Sine is positive and his reciprocal. Tan is positive and his reciprocal. Cosine is positive and his reciprocal. Some of you find that confusing. Hey, what you do, whatever works for you. If you shrink this dude down and you get him on there somehow, it tells you exactly who's positive and negative. You can even write that on your index card. There's not a whole lot going on this test that you guys don't know. So you'll have room to just write it all out. Okay, don't write some kind of code like this. It's going to confuse you. You just write it out, you know? Okay, so here we go. Cosine is 3/5 with theta in quadrant 4. Okay, what is sine? All right, well, first of all, cosine is, and we're going to have to know this, right? We already talked about it, x over r. So easy enough. X is 3, r is 5. Okay, we want sine. Sine is y over r. So we need y, okay? And we're in quadrant 4. So in quadrant 4, you can either think about is sine positive or negative, or you can think about in quadrant 4 is y positive or negative. Either way, what's my y going to be? Yeah, negative, right? He's going to be negative for quadrant 4. No, because remember in quadrant 4 down here, x is positive, but y is negative. Okay, so y is going to be negative. Now we need to know what y is. How are we going to find that? That's right. I don't know why, but if you start to panic, I don't know, but it's always this. Okay, so there you go. All right, here we go. We have x squared, that's 9, plus y squared equals 25 squared. That's 5 squared. Okay. Y is 16. We're going to take the square root. Oh, sorry, y squared. He could be positive or negative 4, but since he's in quadrant 4, we already said he's got to be negative 4, right? And that's going to make sine negative, which is great because the only person that should be positive is cosine and his reciprocal. So I wrote all over the place, but sine theta then is going to be negative 4 over 5. There you go. Okay, because he's y over r. Everybody all right with that? So when you start seeing quadrants, that's going to determine positive or negative. So be really certain you know where those are. All right, now we just actually want a sorry, Daisy.
So it's like I don't know how to say it.
That's okay.
But the x's and y's, they're positive or negative, but the sign, like the actual sign thing is negative or positive.
Okay, yeah, so x and y can be positive or negative. And the like sign, the functions can be positive or negative. But remember, those functions are made up of x's and y's. So to determine that he's negative, you have two ways to look at it. You can just look at the function and say, okay, well, in quadrant 4, these are the only two positives. So I'm definitely going to make sign negative. Or if you don't even want to think about that and you're really confident with your x's and y's, you know that to get to quadrant 4, to get down here, you'd have to have a positive x value and a negative y value, because that's how you get down there. So your x will be positive and your y will be negative. And then whatever happens with sign happens, you know, it'll all come out in the wash, but either way, you'll come up with a negative. Does that kind of make sense? I think you're overthinking it. I really do, but I can't quite get the thing to break through. Yeah. Okay. Anybody else on that? Okay. All right. Let's think about this next one then. Okay. So there's going to be 2 quadrants where tan is positive, and there's going to be 2 quadrants where sign is negative. And then there's only 1 quadrant that's going to satisfy both of these. And that's the quadrant we want. So let's think. Now we can't think about x and y, okay? Because that's not helpful really. We got to think about tangent. So tangent is positive, that's greater than 0. Here, because everybody's positive. And tangent is positive here, because that's the rule, right? All right, because y over x would be positive. Okay, now where is sign negative? All right, well, sign's positive in quadrant 1, so we don't want that. He's positive in quadrant 2, we don't want that. That means he's going to be negative in quadrant 3, and he's going to be negative in quadrant 4. Okay. So there's only going to be 1 quadrant that then satisfies both of these, which is going to be the 3rd one. And there's your answer. Okay. Is that a little better?
So we're looking for the negative one,
Huh?
the negative one, not positive.
For which one? This
For
guy?
sign.
Oh, yeah, because see, it says less than 0.
Okay.
So we want negative. Tangent is greater than 0, so we want positive. Yeah. Okay. All right. Everybody else okay? Okay. All right. Number 15, so easy, right? Name the 6 trig functions. Okay. I don't even care if you put a theta after them or not. You can just put the little words. Just name them. Okay. Then you're going to name their little reciprocals. It's easy to know tangent goes with cotangent. Remember, these are the opposites. S goes with C. All right, then we want to know, are they even or odd? Okay, so everybody's odd except 1 pair. Do we remember the 1 pair that's even? Mm-mm. Cosine. These guys are even. Everybody else is odd. Okay. So if you need to write that on your card, that would be a card thing. I didn't write it on the board. Okay, so write your quadrants, know your quadrants, and know that cosine and secant are even. Everyone else is odd.
Can you tell us the y?
Well, you'd have to derive it from points, but basically what it means is that if you have this or this, you're going to get the same thing. So if you come over here, cosine of 90 is 0. Cosine of negative 90 is also 0. Okay, but like sine of 90 is 1. Sine of negative 90 is negative 1. So it's not the same thing. Does that make sense? It's the opposite. So that's kind of sine. It just has to do with sine being the y, and it doesn't work out that way. He's always negative, but cosine being the x has places where the negative and the positive rotation doesn't matter. It gets the same value either way.
Okay.
Okay, let's look at 16. Okay. All right, so again, we already have this information written on our card, or we're going to put it on our card, but we know sine is y over r. We know cosine is x over r. Okay, now we want to find tangent. We don't even need x squared plus y squared equals r squared because we have x, y, and r. See that? We have everything we need. Our x is going to be -4. Our y is going to be 8. And our r is going to be 9. Everybody got that? So what is tangent going to be? He's y over x, so he's going to be 8 over -4. And he's -2. Okay, how do you know that? Now I know the negative is written up there with the 4, but how do you know the negative goes with the 4 and not the r? Can't have a negative radius. Can't have a negative radius. Okay, good. All right, now we want our calculator again. This is the only one where you must be in radian mode, where your mode matters. This and the graphing, okay? So if you want to just put it in radian mode and leave it and don't ever take it out, that's fine. You can do those other degree things we did in the beginning in radian mode. That's perfectly fine. You can do everything in radian mode. Okay, because you're putting in a radian measure, and if you're in degree mode, you're going to get the wrong value. And somebody does that every single time. Okay, so here we go. Let's try that. Okay, so mode, make sure you're in radian and then quit, right? Mode, radian, then quit. Then we just want cosine. I'm only going to ask you one of the big three, cosine, sine, or tangent. I'm not going to ask you to find the reciprocal, okay? So it's really easy button right on the calculator. And then we're going to do pi divided by 7. There you go. 2 decimal places. Easy enough. Now let me show you though, if I'm in degree mode and I do cosine pi divided by 7, I don't get that. And you're going to get the wrong answer and you're not going to know that it's the wrong answer. So make sure that you're in rad mode. Just put it in now and just stay there. You don't need to be in degree mode for anything on the test. Okay. Okay, next one. Use the identities and properties. Now you got to think back to the properties that we talked about in the identities. Give the exact value of this expression. Sine squared 38 degrees plus cosine squared 38 degrees equals what? 1. How'd you know that?
I don't know. I remember it from the back.
Okay, Ish is some kind of little trig genius. Okay, so if you think back to the Pythagorean theorems that we talked about in section 6.3, this is one of them. All that means is that if you have sine and cosine squared and they have the same angle, I don't care what it is. If it's the same angle, answer's 1. Yours is going to be the same angle, okay? You're good. They're going to be squared, the answer's 1. So don't get bogged down on that one, okay? All right, number 19. We're going to use the fact that the trig functions are periodic. That means these are going to be more than one revolution. We're going to have to subtract out a revolution or a rotation to find the exact value of the given angle or expression. Okay, so we're in degrees, sine of 750 degrees. Okay, what am I going to subtract out to figure out what I really have? Yeah, how about,
That's what my
oh,
math
so you
lab
did,
said.
you subtracted out too. I gotcha. I was like, what in the heck is
Yeah,
happening in
my
here?
math lab said subtract how many you can
Oh,
get it like
I
that.
can't remember that. I just do 360 till I see one I like. Yeah. Okay. All right. So, subtract 360. Okay. And then we're still not within one rotation. So I'm going to do it again. Okay. So what they did is they just subtracted at 720. They subtracted 2 rotations right from the get-go. Okay. And you get sine of 30. Okay. If you know what sine of 30 is, he's 1/2. If you're not sure, There's where your unit circle comes in. Okay, you go to 30 degrees. Here's cosine. Here's sine. Sine's 1/2. Ta-da. Okay, sound like a plan? Okay. All right, let's look at 2 more and then we're going to graph and look at the bonus. Okay, so now we're getting into graphing. So, hold on, I just threw my unit circle on the floor. Okay, so remember, your actual equation for graphing is going to be your amplitude, your function. I'm just putting it in parentheses so it doesn't look like I spelled the word a function, which is not a word, right? Okay, then B, then X minus a phase shift. So I'm going to put PS, that's a horizontal movement, plus or minus VS, which is a vertical shift. So that's your whole situation there, right? So you have your amplitude, whatever of the 6 functions it is, your B, X minus a phase shift, that's in parentheses. If there's a horizontal movement, it has to be in parentheses. And then added or subtracted in the very back is the vertical movement. Okay. All right. So we have a little thing here. It wants the amplitude and the period. That's all it wants. Now, remember, the amplitude is the absolute value of A. So if A is positive or negative, it doesn't matter. You're going to take the absolute value. So even though this is -3, what's my amplitude? 3. That negative out front has nothing to do with the amplitude. All that's going to tell you is sine has been reflected over the x-axis. That's just for graphing purposes. Okay, now it wants the period. So remember, your period, this is something you may want to write on your index card, is 2 pi over B. Okay. My B is whatever's in front of X. Now you can just move him right out if you want to. He doesn't matter. Sometimes they put parentheses around that. Sometimes they don't. There's no phase shift because there's no positive or plus or minus next to the X. But here my B is definitely 4. Okay. So my period is going to be 2 pi over 4, which reduces to pi over 2. And there's your period. Okay, so amplitude is positive. Period is going to be 2 pi over B because you're either going to have sine or cosine. You don't have to worry. I know tangent and cotangent have a period of pi, but you're not going to have to worry about those two. You're only going to have sine or cosine. Okay. All right. Is everybody okay with that? All right. Let's see. Okay, the next problem, number 21. I know those aren't unit circle values, but just go with it. Just, I guess I should just say on a random circle in the universe. Okay, so just get rid of that if that bothers you. Okay. What is sine and cosine? All right. Well, this is a point. What do you think we have to do? Why do you feel stupid?
Because they're right there.
They're right there. You're not supposed to have to do anything. This is what? Cosine. What's this? Sine. You're done. Okay. So cosine is here. That's why I had it for unit circle. I knew there was a reason I did it. Because there you go. So just pretend that that's on there somewhere. Okay. So all I want you to do is know that the x value of the point is cosine and the y value of the point is sine. That's it. Okay. Everybody got it? Okay. All right. Now let's talk about graphing. Okay. So you're going to have 2 graphing problems. Let's look at this guy first. Everybody okay on everything else? Kind of? Okay. So it's going to go ahead and it's going to give you 4 choices. So you don't have to worry about making the graph. You don't have to worry about making the jumps. The jumps are going to be labeled for you. You don't have to worry about any of that. Okay. But let's see if we could go ahead and do this. So I notice that this negative means I'm reflected over X, okay? The 2 means I have an amplitude of 2. I see cosine, which means normally that's a cup, right? Normally that's dum. But because I've been reflected, I'm going to be dm right? I have to go the opposite. My middle stay, but these are going to be reflected. I'm going to end up going like this instead because of that negative out front. Okay, I don't have a b. My b is 1. So my period is 2 pi. That's already there for me. If I take my period divided by 4, that gives me the jumps. Okay, oops. They're already there for me. I don't have to do anything. Okay. Oh, but you can't read it. Thank you. Okay. But I don't have to do that because they're there for you. Okay. All right. What does this mean? Plus pi over 2. That's a horizontal movement of pi over 2 in which direction? Left. Okay. So I'm going to move left pi over 2. Okay. So I'm not going to start on the y-axis. I'm going to start to the left of that. That's why this negative pi over 2 is here. You're going to be starting over here.
Wait, where do you get the jump, the 4?
Oh, because there's 4 jumps.
Oh,
So you always do that. Divide by 4. Okay, do I move up or down? No, nothing to the back, which means this is the middle. Okay, now my amplitude is 2, which means this is my up and there's 2 between it. That means this is my down and there's 2 between them. Right? Everybody okay on that? Okay, now here we go. I'm gonna put in my points, but I'm not starting on the y-axis. I've been moved left pi over 2. I'm starting over here. So I'm gonna start down because I've been reflected, middle, up, middle, down. And so I'm gonna end up looking like sine, really. But there's my graph, okay? And if you wanted to, he's gonna come back up here. All right. Does that make sense to everybody? We started over here, we were reflected, so we couldn't go up, middle, down, middle. We had to go down, middle, up, middle. Okay, we got all our points in. All right, let's look at the calculator a minute. Okay. All right, so we're in radian mode because I told you to put it in there and don't touch it. Okay, let's go to y equals. Everybody able to get to y equals? I'm trying to find a place you can see. Right there. Okay, so let's put in this function. Let's do -2. -2 is not -2, right? -2 cosine x, here's your x, it's right here next to alpha, plus, now put pi over 2 in parentheses. So you're going to have 2 parentheses after him, one for this guy to close it and one for that. Everybody okay with putting that in there? -2 cosine x plus that. Okay. Now, you can't just hit graph because you're not going to have the same picture as what's pictured. You're going to have to adjust your window so that you can clearly pick of the 4 choices. So we're going to go to window. Okay. Now, maybe you remember from college algebra how to handle a window. Let's look at this. Okay. Our x min for our window says -pi divided by 2. That's what I put in. What's my x max? 2 pi. I'm going to scoot down to 2 pi. Don't worry, it's going to change it to a decimal, but that's okay. The x scalar is your jump. So we already found our jump. It was pi over 2. Okay. All right. Now let's look at y. Okay, our y min on the graph is -3. Our y max on the graph is +3. What's our y scalar? What's our jumps for y, our tick marks? Just one, right? Just one for him. They're usually just one. Don't worry about X resolution, you're good. Now we're gonna hit graph. That's exactly what we just drew. So if you want to do it that way, all you have to tell me is A, B, C, or D. You can match the choice to your little picture, but you have to be able to handle window. If you can't handle the window, you can't do this. You got to know how to do that. Otherwise, it's going to be super weird for you. Okay. So X min, X max, you don't have to come up with that. It's right there on the little answer choices. These are your scalars. Y min, Y max, your scalars are 1. And then you just hit graph. Okay, and you've got it. Sound good? Okay, let's get to our next one because I want to be able to get to the bonus. Okay, last actual test problem is this. Okay, so according to this, this is one of those weird ones that we talked about in my math lab. Where should that 4 be? On the other side, for crying out loud. And should I have a coefficient in front of X? No, so I'm going to pull out a 2. I got a lot to handle. So I'm going to have 1/3 sine 2, because I'm pulling out a B. I'm going to divide both of those terms in parentheses by 2, which is going to give me X minus pi over 2. And then there's that +4 in the back. So that one had to be completely redone, and it's got everything you can think of wrong with it except the reflection. Okay, does that sound good? Now look at my amplitude, 1/3. So that means it's not going to be real big. It's going to be super duper tiny, right? It's barely going to go up and down. All right, so here we go. This is when the window is so important. All right, well, we already have X min, X max. We have Y min, Y max. My X scalar is pi over 4. My Y scalar is 1. But if we want to do this by hand, we're going to do it both. I notice my amplitude is 1/3. Okay, I'm sine, so I'm going to be mum-D, right? Middle up, middle down. I'm a little rolling hill. Okay, my B is 2, so my period is 2 pi over 2, which is just pi. That makes sense because that's all I've been given anyway. I mean, you know, spoiler alert, they only give you 1 period anyway. Okay, my jump is going to be pi over 4. Again, look, it's already there, pi over 4. Okay, because I just take period divided by 4. I do have a horizontal shift, a phase shift. So minus pi over 2 is going to be pi over 2 where? To the right. Good. So I'm not going to start here at the origin, right? I'm going to start at pi over 2, which is right here. Okay, that's super weird, but that's where I'm starting. Okay. Then I also have a vertical shift. Sorry, you can't see that. Vertical shift of +4, which means 4 where? Okay, 4 up. So let's draw our up, middle, downs. Okay, so this is not my middle anymore at X. My middle has shifted up 4. Okay. This is my new middle. Okay, now my amplitude is 1/3. Kidding me? Okay, so let's just pretend this went up 1/3. And in there is 1/3. And then you're going to pretend to go down the best you can. You can see how little it really is. 1/3. Okay. All right. Now, since I'm starting at pi over 2 to the right, I got to add in a couple of more jumps to really get a whole period, right? So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. I'm going to stick in a 5 pi over 4. And then let's see, 6 pi over 4 would be over 2. Okay, just to give me a few more. All right, I think we're ready. Think we're good? Okay, so I'm not going to start here. I'm going to start at pi over 2 in the middle. Okay, there's my starting point. And then I'm going to go up, middle, down, middle. Okay, and then if you wanted to kind of finish it and connect it to the y-axis, you could. That would be a down, middle. Okay, but you're looking like this and you're pretty darn tiny. Okay, everybody see that? You're pretty darn tiny there, just barely moving. All right, I'm going to go ahead and put this into my calculator. All right, now you don't even have to change it, because what if you make a mistake? Just take it right from here. I'm going to do 4 plus 1 divided by 3 sine 2x minus pi. I just put it in the way I see it. I don't even have to rearrange over the calculator, because your calculator does that for you. That's the point of the calculator. Now remember, you're going to have to hit window. Otherwise, it's not going to come out. Okay. Oh, I hit the wrong thing. Okay, window. Now, we already said my x min was 0. My x max, now, if you're just matching it up to the window, I wouldn't worry about the 5 pi over 4, or the 3 pi over 2. I would do exactly what, the choice is, which in this case would just be pi. And my scalar is pi divided by 4. Okay. My y min is 0. My y max is 5. Your y scalar is always 1. And then graph. And sure enough, there he is, just like barely moving along. And that would be your graph. Okay, all stretched out. So you can either do it calculator or by hand, but then you just got to write A, B, C, D in the blank for me. Okay. All right, let's look at the bonus then. Is everyone okay on the graphing? Okay. All right. So the bonus goes way back to section 6.1, and it does the little conversions. Okay. So let's look at what you need to know. Okay. You have a piece of equipment that contains a gear that's spinning at a rate of 5,000 revolutions per minute. Okay. The gear has a diameter of 8 centimeters. Well, we don't use diameter. What piece of information are we going to get from that? And that's going to be 4 centimeters, right? So if you're not so sure about that, diameter divided by 2. That's how you get your radius. Okay. This wants linear speed. Okay, so that's going to be another thing you're going to want to write on your card, linear speed. Now, linear speed is S over T, but we know another way to write S is R theta. And we're actually going to do it this way. Okay, R times theta over T, because we have a radius and we're going to change this into rads over whatever time we want. So make sure this is on your index card. Okay. And it wants it in kilometers per hour. So we got a lot of conversions-ish. This is just conversion up the wazoo. Okay. So here we go. A few things we're going to need. First of all, I can't have revolutions. I need to change revolutions into some kind of radian. How many radians is 1 revolution? 2 pi. Okay. There's a conversion you need. Write it on your card if you need it. Then I have minutes, but I want hours. Surely you guys know that, right? But come test day, some of y'all don't know your first name, so you may want to write it. Okay. All right. Then here's the kicker. We have centimeters. We want kilometers. Now, depending on how much you love conversions, you could say, oh, there's 100 centimeters in a meter, and go to meters. And then you could know that there's, what, is that 1,000? Meters in kilometers, something, you could just move your little self right along there, or you can do it all at once and know there's 100,000 centimeters in a kilometer. Okay, so you could take it step by step and go through meters, but let's just get it done. There's your conversion. Okay, this is what your units are going to be on the test too. All right, here we go. Let's jump right in. I already have my radius. Let's go ahead and change him. Okay, we don't want centimeters. We want kilometers, kilometers, whatever you like to say. Pecan, pecan, there you go. Okay, so this is my conversion. I want to get rid of centimeters and cross it out. What's going on the top? Which side? The kilometers. Because remember, the key to this, when you make a fraction, you want to be able to cross them out. Okay, so if I do 4 divided by 100,000, oh my gosh, Ms. Holcomb, this is not right. Something is wrong with my calculator. Okay, that's just because your calculator's lazy and doesn't like to write zeros. This is your calculator's way of writing scientific notation, right? It's really telling you, when it tells you this, it's telling you 4 times 10 to the negative 5. You guys know how to handle that. The negative means, here's your decimal, and you're going to scooch over 5 places. So you're actually this many kilometers, right? That's all it means. So don't let that throw you off. Everybody see that? This is the same thing. 1, 2, 3, 4, 5. Okay? Everybody okay with that? Remember that deal? Okay. So great. We have our radius. Now we need theta over t. Okay. So I have 5,000. That's revolutions per minute. Okay. All right. So let's change revolutions first. Here's our conversion. We want revolutions to cancel this way. So who's going on top? The 2 pi, right? Because we want the revolution to cancel. Okay, you think we can keep going? Okay. Now so we have rads in the top now. Now we need to change minutes to hours. Here's our conversion. We want minutes to cancel this way. So who goes in the top to cancel? 60 minutes. Okay, there we go. All right. Now we're going to round this to a decimal place. So we want to just throw in the pi symbol and everything and get this going. Okay. So now we're going to multiply all the tops. So 5,000 times 2 pi times 60. And then divide by everything in the bottom. But everything in the bottom is a 1. So you don't really have to do that. Okay. So we are left with this big giant honking number, okay, which is actually radians per hour. Okay, everybody all right with that? Okay, we're still not done. That's why this is a bonus. Here's your linear. You can't even see that, but I wrote a V. Okay, my R is 0.00004. Right? That's kilometers. And my theta over t is this big long thing. Notice I didn't round anything. I'm writing down everything. Okay. Now you could put your units here. The radians are kind of going to get absorbed in the calculation. They kind of go away. They're there. We know it's in radians because there's a theta in the formula, but your units are going to come out a nice little kilometers per hour. Okay, so now if you have this in your calculator, make sure you know this trick to save you some time. We're going to do 0.00004, right? Times, and then I want to times it by this. Just scoot up and hit enter, and it'll put it right there, so you don't have to just tap your little finger so many times. And there you go. And you're going to round that 75.4. And that is your answer. So that's a lot, but that's why you get the big points for it. Okay. Oh, we only get 5, but still. You still got a riddle.
We still have, like, we already have 2 extra credit things, right?
You no, just the one. You had the get on the My Math Lab. So that'll be added to it. And then you have this, and then you'll have a riddle. So you got a lot. Yeah.
What's the 24 questions?
Oh, also, good, Joy. Okay. So then the other extra credit, don't forget, is the practice problems, those optional practice problems. If you do 24 of those, that's another one. So my goodness, people.
And you just have to do those before the classes. right?
You do. Those stay open. Right. Yeah, so get your My Math Lab stuff done before Friday. And if there's any donuts left, grab those. I didn't mean to keep so late. Oh, wonderful. And here's index cards. If you want one, here they go.
Strawberry or white? Strawberry.
See you later. Bye. No index card takers? Okay.
I'm getting one.
Okay.
Hold it right there.
Take a couple. Bye. See you later.